Welcome back, students. Good morning, all of you. Today we are going to discuss delicate portion from CBSE from chapter number 5. As we know, we have the list. Few portions are deleted, but as per our government, Gujarat government, you know very well that guideline is still it is not with us. So we have to prepare for all the syllabus, right? In chapter number 5, we have seen yesterday about ferromagnetic material. What is ferromagnetic material? The material which having permanent dipole moment like paramagnetic material. Clear? Such material is known as ferromagnetic material. That ferromagnetic material is made up of domain structure, right? And each domain consists of 10 raised to 11 atoms, right? And that 10 raised to 11 atoms having a permanent dipole moment. But when you combine all these small domains, it will form a ferromagnetic material. So all the domains are arranged randomly, and because of that reason, that ferromagnetic material do not possess permanent dipole moment. Each domain having permanent dipole moment. But when we are combining the domains, that domains are the small particle of ferromagnetic material which itself behaves like a magnet. When such domains we are combining to form a ferromagnetic material, all the domains having dipole moment, that dipole moment is permanent. But for the combination of all the domains, all the dipoles are arranged randomly. And because of that reason, ferromagnetic material do not have permanent dipole moment. Is it clear? Okay. Now, such type of material we are going to do magnetized, right? So, suppose this is a ferromagnetic material. That ferromagnetic material you have to insert into where? Inside the solenoid. Clear? Right? Here, like that fingers, number of turns of wire is there, right? From that wire we have to pass electric current, and that electric current is symbolized as I. Here it is free of that material, so it is symbolized as IF. Clear? Now such type of material means ferromagnetic material we are placing inside the solenoid. So on passing electric current outside the solenoid, magnetic field produced inside the ferromagnetic material, right? So how that magnetic field produced inside the material with respect to current passing through the solenoid. So if we will draw the graph of that both physical quantities, that is known as hysteresis curve. So students, in chapter number 5, in this revision video, we are going to discuss about FM. What is FM? FM is nothing but ferromagnetic material, and in this FM, we are going to discuss hysteresis. Clear? So, first of all, we have to know that what is hysteresis, right? Hysteresis, it is a graph. It is a graph of, that is B, magnetic field produced inside the material against IF, that is electric current passing through the solenoid, right? Or you can say that H, magnetization intensity. Clear? That small if, this symbol is not there in our new textbook, but if you will see the reference book, then instead of H, capital I is written, and that capital I is considered as electric current passing through the galvanometer. Clear? Okay. So what is hysteresis curve? It is a graph of magnetic field produced inside the material against electric current passing through the solenoid, or you can say that magnetic intensity. Clear? In ferromagnetic material. Ferromagnetic material means Fm. Clear? So, first of all, what to do? Here, we have placed the material. Initially, electric current is 0. If electric current is 0, then magnetic field produced inside the material is also 0. From there, we are going to start the graph. Clear? So, graph is like this. On y-axis, you have to take that magnetic field, and on x-axis, we have to take that H, magnetic intensity, or you can write IF also. Initially, at this point, electric current is 0. Means here we are taking IF. That means electric current passing through the galvanometer is 0. At that time, magnetic field produced inside the material is also 0. So put it here 0. Now we are going to pass electric current, and we know that when electric current increases gradually inside the material, magnetic field is produced gradually, right? So on increasing electric current, magnetic field increases gradually up to this point, means up to point A. Point A is known as saturation point. That is saturation point. And we know that what is saturation point? So the dipoles which are random, that dipoles are arranged in any one particular direction. After that, magnetization is maximum. Magnetization is maximum. This situation is known as saturation point. So you can say that at saturation point, magnetization is maximum, and then maximum magnetization is symbolized as MS. Clear? Now what to do? Okay, you have to decrease electric current. After saturation point, there is only one option: decrease the electric current. So when we are decreasing the electric current, so here at that point you will get B point. Okay, check it out this point. Here electric current becomes 0, but magnetic field is not 0. So at this point, IF, electric current passing through the solenoid, becomes 0, but magnetic field produced inside the solenoid, or not inside the solenoid, magnetic field produced inside the material is not 0. What does it mean? Means magnetic field retained inside the material. So this point B, is known as point of retentivity. Clear? Now, if you want to make that magnetic field produced inside the material 0, then you have to increase electric current in reverse direction. Means you have to change the polarity of electric potential applied to that solenoid. Clear? So now we are going to increase electric current in opposite direction. So when you are increasing electric current in opposite direction, so at this point means at point C. Check it out. Here magnetic field becomes 0. That means B is equal to 0. But you will get the value of IF. Means here value of H is not equal to 0. Right? So this point C, C बोले तो cat, not a cat, it is a retentivity point and this is coercivity point. Clear? So here we have to think about that 2 points, B and C point. Right? Whenever this question is asked in your exam, if it is asked in your exam, you have to explain these two, retentivity point and coercivity point. Clear? Further, increase electric current in a reverse direction. Again, you will get point. Which point? A, B, C and D. This point is similar to this. Means here in inverse direction of electric current, again you are getting SAT, saturation point. Right? And in this saturation point, we know that M बोले तो magnetization is maximum, and it is symbolized as MS, magnetization at a saturation point. Clear? Now, after this, there is a vice versa process. After saturation, what we have done? We have decreased the electric current. Same way here also. So, start from point A, O, A, B, C and D, and then after you have to write, by reversing the process, we will get a loop like this. Got it? So here we are getting another point, that is DE. It is similar to B. So again, E is also known as retentivity point. Here we are getting F, again similar to this. So it is also known as coercivity point. Clear? Retentivity point and coercivity point plays important role in the types of ferromagnetic material that we will see later on. Clear? Don't worry. Okay? So here you are getting this type of loop, and this loop is known as hysteresis curve. Right? If you will take this means area under the graph. Clear? This area under the graph gives us what it gives: loss of electric energy. Right? क्या है during M बोले तो magnetization. So in the process of magnetization, there is conversion of electric energy into magnetic energy, but this electric energy is lost in the form of heat, and that loss we can obtain from the graph by using area under the graph. Clear? So this is about hysteresis curve. It is of 3 or 4 mark question. If it is asked in 2 mark question, then the question will be like this: draw the hysteresis curve and explain retentivity point and coercivity point. So in that question, you have to draw the graph and you have to explain these 2 points only. But if the question is asked in 3 or 4 marks, so question may be changed. That means explain hysteresis curve in detail for a ferromagnetic material. Clear? So this is about that question. Have a look for a few minutes, please. Clear? Okay. See. Now After this, we have types of that ferromagnetic material. Clear? Ferromagnetic material are of two types. Okay? That we have seen in that today's Zoom video also. So here I am going to explain only one type of ferromagnetic material. Another side is our hot ferrite versa magnet. That means vice versa. Let us see type of FM. FM means ferromagnetic material, and from that we are taking hard FM. That means hard ferromagnetic material. And another is soft. Instead of hard, there is a soft ferromagnetic material. So which point you have to cover? This question may be asked as a difference only. Clear? So hard ferromagnetic material. So first of all, you have to draw the graph of B against H, and that graph is like this. See. Okay? So this graph, this look is like that hatokato, right? Looks like healthy. Means here, check it out. Point of retentivity as well as point of coercivity, right? Here it is H, it is B. You just check it out. Point of retentivity and coercivity are large. Clear? So first point is about graph, and second point is about it having large retentivity and coercivity. Clear? Large retentivity means magnetic field retained inside the material for a long time. Clear? And because of this reason, if electric current, that is, if current becomes zero, if current passing through the solenoid becomes zero, then magnetization, or you can say that magnetic field retains. Means magnetic field which are produced inside the material, it remains forever. Means such type of material is used to prepare permanent magnet. Right? Such type of material is used to prepare permanent magnet. Which are the material which is used for ferromagnetic material? So the last point of this hard ferromagnetic material is, for an example, right? Nico, right? That is an alloy of aluminium, nickel and CO, cobalt, right? This is about hard ferromagnetic material, and another type is soft FM ferromagnetic material. For that, see, whatever I am going to underline, only this word changes. And for an example, that, okay, Let us see first. For an example, it is soft iron, right? Permanent magnet, temporary magnet. For an example, electromagnet in dynamo, fan, radio, etc. Clear? If electric current is zero, in hard ferromagnetic material, the magnetic field retains. And here, soft ferromagnetic material, magnetic field also becomes zero. It having large retentivity and coercivity, soft ferromagnetic material having low retentivity and coercivity. And if we will draw the graph, that graph will be slim like this. Means, check out this graph, healthy and is slim, right? So this is about soft ferromagnetic material, hard ferromagnetic material and its difference. Clear? So 1, 2, 3, 4 and 5. 5 points are enough for 2 more questions. Hope you have a